Okay. So what the question is, you have to, this network is given to you. Okay, I'll just draw the network. Some network will be given to you. Okay, 2 neurons are there, let's say. Any network will be given to you like this. So this is first input x1, second input x2. Okay, and there's bias. This is -1. It could be 1 or -1. Bias is a fixed input. It is 1 or -1. In this case, it is given to be 1. Right? So some weights are given. These are the weights which are given. Okay. O1 and O2 are the outputs of the network. Now, this is some f of net, and this is some f of net, the same f of net. Okay. Now, what is given to you is O1 is given to you 0.28, and O2 is given to be minus 0.73. Okay. And it is given that f of net is bipolar sigmoid. Fine. O1 is given, O2 is given, f of net is bipolar sigmoid. What you need to do is you need to find x1 and x2. Okay, are you getting the problem? This network is given to you along with the weights. O1 is given to be 0.28 and whatever these values, and the activation function is also given to you. Okay, now the problem is you have to find the inputs, right? So how will you proceed? How will we proceed? What is f of net? We have all the only one unknown is there, that is the input. We have the outputs also with us. We know how the outputs were computed. We know how O1 and O2 were computed, right? So how will we compute that? How will we use that to our advantage to find x1 and x2? Yes. O1 is given to be 0.28. But how is O1 computed? What is O1? What is the formula for
Del
O1?
del W equals to W1.
O1 is given to be 0.28. But O1 is nothing but f of net.
Yes, ma'am.
Okay. And what is f of net?
Bipolar
It is
sigmoid.
bipolar sigmoid. So what is that bipolar sigmoid? We'll write that equation 2 upon 1 plus e raised to. So e raised to minus net
Net.
minus 1. Right. Now what is this net? Net is very important. What is net?
Net is
Net,
the
yes.
net is the sum of all the weights multiplied by their respective
Exactly,
inputs.
exactly. Very good. So net is nothing but weighted sum of inputs. Okay. This is W transpose X. That is how we define it. Now the net for this neuron. If I look at the network closely, what is the net for this neuron? This neuron.
-1 plus 2x1
Yeah,
minus x2.
so I just need to consider these weight vectors, right? So first of all, what will I do? I will write W1 weight vector, which will represent the weights coming into this neuron, and I will write W2, capital W2 weight vector, which will comprise of the weights which come into this neuron. Okay, so what is W1? W1 is
2.
1. No, W1 is 1, 2, -1. It's a weight vector,
Oh, okay, right.
All the weights. So it is 1, 2, -1. W1 is 1, 2, -1. What about W2? Minus half, 3 by 4, right? So W2 is minus half, 3 by 4. Okay. Now that I have W1 and W2 with me, what is O1? I have to consider W1 while computing the net. Okay. Let me call this as net 1. What is net 1? Net 1 is equal to W1 transpose X. Are you getting it? The weights which are connecting to that neuron, the first neuron, is the W1 weights, right? So W1 transpose X. So I can write this as what? 1 plus e raised to minus W1 transpose X, right?
Yes, ma'am. -1.
Okay, -1, right? Okay, I have W1 transpose X with, I don't have X with me, so X also I need to write. So what is X now? I have X1 and X2. Let me write X also as a vector. X is 1, -1 is the bias which is given to us. I'm going back to the network. So look at X. X is this vector, right? This vector. So remember, you consider in the order in which you are putting the weights. Huh? Don't multiply it. I mean, don't write something x1, x2, and -1. Usually, we write the bias towards the end. Okay, we can write it at the end, or we can write it at the beginning of all the other input features that we have. Are you getting it? X1, X2, and then bias, or bias followed by X1, X2. In this case, we are just following what the network is showing. Bias we have placed at the top in the network. Okay, so correspondingly, that weight we have to multiply with the bias, right? -1 that you see here, the fixed input that you see here, has to be multiplied with which weight? With the weight which is getting connected. So in the case of W1, this vector, it will be multiplied with 1. In the case of W2, it will be multiplied with which value? In the case of W2, you will multiply it with which value? -1, you are going to multiply with which value?
With 1.
Minus half. See,
Oh, sorry,
how
W2.
W2 -1, you are going to multiply with this minus half, na, to what I'm trying to say, how do you compute W transpose X? You multiply the corresponding weights with those inputs, na, which are coming in. So be careful when you're writing the vector. That is what I'm trying to say. If you're writing it in the reverse fashion, x1, x2, and -1, then that W1 will change, W2 will change. Are you getting it? What I'm trying to say now? The order will change now of the
Yes,
vector. So you are bound to make a mistake here. That is what I'm trying to point out. Okay. So now we are considering bias, input 1, input 2. That is the order. So that is why the weights also we have written accordingly. 1, 2, -1. First is the bias weight, then is x1, then is x2. Okay. Next. Now we have this x1. So what we were doing, we were in the process of writing our vector for inputs. So it is -1, x1 is unknown, x2 is unknown, right? So this is our input vector. So these are the weight vectors and the input vectors. Now we have formulated all our vectors. Now what we will do is, we will write x here. So we will write an equation for net1. So it will be 1, all these are vectors we have written horizontally. So transpose. So it is 1, 2 and -1 multiplied by this vector, right? So you will get an equation in x1 and x2. What are you getting? Net1 is nothing but, solve this, just write, tell me the equation that is coming.
-1 plus 2x1 minus 2x2 minus x2.
Correct. Minus x2. Okay, so this is the equation. So net1 is this, right? Similarly, you will have another equation for net2. What is net2 equation? Net2 is nothing but W2 transpose X. What is this equation now? I'll have to use W2 weights. So I'll just scroll up a bit. W2 weights are minus half, half and 3/4. I'll write it here. Minus half, half, 3/4 times the input vector. Right? Okay. So now you tell me what is this? The equation for net2?
Half minus half x1 plus 3/4 x2.
No, half, yeah, half minus, no, plus half x1. It's minus or plus? It's plus, na?
Ma'am, initial one is minus half, no?
Minus half
From
into -1 becomes
okay,
half,
one.
right? So half x1 plus 3/4 x2. So now we have two equations. One is for net1, one is for net2. What do we need to now? What is remaining now? Okay. We need to now substitute here and somehow equate, right? See, O1 is given to us. So 0.28 is equal to 2 upon whatever, 1 plus e raised to minus this equation, -1 plus whatever. Okay. So then what you need to do? Plus 2x1 minus x2, right? -1. This is our first equation, and second equation will be for the second O2. Okay. Now what do I need to do? I need to take that unknown terms on one side. I need to rearrange this and get the constants and get an equation in x1 and x2. Are you getting it? Okay. I will tell you a shortcut for this because the activation function is bipolar sigmoid. So what is the meaning of that? It is tan h of x/2. No? Do you recollect?
Yes, ma'am.
So you use this to your advantage. So it is something like tan h of this x here will be W transpose X, W1 transpose X, net1, right? X is nothing but net. Let me write this as net/2. Okay. So tan h of net1/2, correct, is equal to 0.28. Can I write it in this fashion? tan h of net 1 by 2 is equal to 0.28. Can I write it? Okay.
Yes.
Then what do I write? Tan h of, okay, I'll just put these terms here. So half ho gaya sab. So minus 0.5 plus, look at this equation. Minus 0.5 plus x1 minus 0.5 x2, right, is equal to 0.28. Okay. What can I do now? Tan
Tan
inverse
H
I can,
inverse.
tan h inverse. So tan h inverse if I take now on both sides, then I will get simple equation, linear equation. Okay, tell me what is it? Tan h inverse of this 0.28.
Equation wise, ma'am, half ln of 1 plus 0.28. Yes.
हाँ, ये क्या है इसका? Tan h inverse of 0.28.
Half ln 1 plus 0.28 upon 1 minus 0.28. Equation.
Tan h inverse of 0.28 क्या है वो बोलो मुझे.
0.2876.
0.2876, correct. And then you rearrange. समझा ना अभी ये कैसे आया equation? So you will get one equation in, this is equation 1. इसको rearrange करना पड़ेगा. So you will take that 0.5 there or whatever you will do. Okay. So actually this equation becomes x1 minus 0.5 x2 और ये 0.5 उधर जाएगा. ठीक है. So what will you have? 0.7876, right? This is equation 1. On similar lines, can we get equation 2 for us now using O2 and net 2? Okay, come on, who will tell me equation 2 now? Equation 2, what is equation 2? I want the equation 2 here. Use O2. What is O2? O2 is minus 0.73. O2 is minus 0.73. We have our net 2 ready with us here. Let me use another color. This is net 2, right? O2 is minus 0.73. You use these two, use tan h, you use the same concept and tell me the second equation that you're getting. So if you have a calculator, if you're used to using an engineering scientific calculator, I think you will be able to also solve linear equations if you don't want to solve it like that. Okay, by hand if you don't want to solve it. You know how to solve linear equations using your calculator, right? Linear, quadratic, whatever. Yes?
Yes.
Yes.
So if you're good at that, you can use the calculator for solving. Even in other problems, if wherever there is some term, wherever there's an equation to be solved, you can use it. Even in for integration and all, you can use, like the earlier fuzzy problems that we have solved, you can use the integration functionality, definite integrals that is available, or derivatives, whatever is available. So since because of lockdown, we are not used to using the calculators, but still you do it for the final exam. For this exam, you have to use for solving the problems. But for fuzzy and all also you can use, where you have to actually use that, solve the defuzzification problems. There the integral term comes into picture. There you can use it effectively. Okay. So what is the second equation? Yes.
Ma'am, is it 0.4x1 plus 0.375x2 equal to minus 1.328?
0.4 x1. No, I am not getting it as
0.25, 0.25x1,
0.25.
0.25.
Huh. What you have done is you have taken that as
Yes,
0.4.
0.25x1 plus 0.375x2.
Yes, correct. Is equal to minus 1.1787.
Yes, minus 1.17.
Okay. So what is the answer? You have to solve these two equations to get x1 and x2. What is x1 and x2 then? So such kind of a problem can be asked. Anything you can vary the activation function. Are you getting it now, Harsh? You were asking na yesterday.
यस
हर्ष?
मैम, बट ये वाले में 10h से इजीली हो जाएगा, अगर वो
हाँ तो
यूनिपोलर
वो
आया तो बहुत
I
लंबा हो
know,
जाएगा.
I know. Any activation function I can give. It is not necessary that it will be a sigmoid only. It could be anything. So which
मैम
will
तो
be,
उसमें
it
हम
could
ऐसा
be a,
कुछ
it could be a linear activation function. It could be something which is, you can solve it in that much time.
मैम तो लाइक उसमें हम लोग आउटपुट को जो दिया है उसको चेंज कर सकते हैं, लाइक 2 से मल्टीप्लाई करके -1 करके फिर 10h यूज करें, ऐसा कुछ.
मतलब टू नहीं समझा मुझे आपका
लाइक
क्वेश्चन.
यूनिपोलर सिग्मॉइड है तो उसका एक्टिवेशन 1/1 प्लस ई रेज टू माइनस नेट
हम्म
होता है.
हम्म.
मुझे उसे 10h के टर्म्स में लेके आना है, तो मैं जो आउटपुट के साइड है.
हाँ, मैनिपुलेशन कुछ भी करो आप. आपको
ओके.
फाइनल आंसर सही, आपको आपके ऊपर है ना, आप क्या ट्रिक यूज करते हो. वरना फिर आपको यू विल हैव टू टेक दैट 1 प्लस ई रेस टू पूरा उस तरफ वो सब करना
वो
पड़ेगा
बहुत
वो.
लंबा जाता है
हाँ
इसलिए.
हाँ हाँ. सो इधर ऐसे कुछ रहेगा या कुछ लीनियर फंक्शन दे दिया, मैंने फंक्शन ही दे दूंगी ना आपको, तो आपको वो ऐसे ही रहेगा, तो सो दैट यू कैन बी एबल टू सॉल्व. ओके, ओनली थिंग यू हैव टू बी केयरफुल अबाउट द ऑर्डर ऑफ द वेट्स, द इनपुट्स, वहां पे थोड़ा सा ध्यान देना होगा कि आप वेक्टर ही ना रॉन्ग ना लिख दो ना.
मैम अगर सिमिलर काइंड ऑफ प्रॉब्लम आप डिफरेंट एक्टिवेशन फंक्शन के साथ अगर आपके पास सॉल्व किया हो खाली सोल्यूशन के साथ, वी कैन ट्राई द मैनिपुलेशन.
Okay, I'll try to give you.
Ma'am, final x1 is minus 0.5873 and x2 minus 2.7498.
x1 is equal to क्या मिला आपको?
Negative 0.5873.
एक मिनट. Minus 0.5873. Okay, and
Yes,
x2 is
minus 2.7498.
मुझे 2.75 मिल रहा है. Okay, 2.749 ना. Harsh, what are you getting?
सेकेंड वाला -2.7512 आया.
हाँ, मुझे भी.
फर्स्ट
वो
वाला
क्या
बहुत.
रहता है ना शगुन, यू हैव थोड़ा डेसिमल्स का देख लो ना, वो 4 डेसिमल है ना, शायद आपने वो राउंड अप किया है. सो सी, general rule is na 4 decimal places you have to consider. Uske beyond it is okay, but 4 decimals you have to consider.
Yes.
So if you consider that, then it will match exactly. But utna tolerance that I will keep, don't worry about that. So the kind of like these kind of questions na, many times what will happen in this particular ISC, MCQ नहीं रहेगा. आपको कोई सपोज ऐसे दे दिया x2 फाइंड आउट करो या x1 फाइंड आउट करो, तो आपको वैल्यू लिखनी होगी टेक्स्ट बॉक्स में. And that will be evaluated whether your value is correct or not. If you have given any NPTEL assignments, किया है कोर्स आपने कभी NPTEL का? Yes. So you have to enter in the text box rather than MCQ. So that value could be will be validated.
So we don't have to scan and submit. We just have to put in the values in the text box.
हाँ नहीं वो करना ही है आपको. See कैसे करना है आपको. See how the exam will be there. You have to, the problem will be given to you and you have to answer that there. But solving का part है ना, आपको ready रखना है paper का, और उसको I'll give you remaining half an hour or whatever is there, time is there 20 minutes to upload. The solution has to be there na, otherwise then there's no point.
Ma'am, it's not necessary to be stepwise na, like while solving.
ऐसे कुछ तो calculations मुझे दिखने चाहिए ऐसे जैसे मैंने अभी किए. वो
Yes ma'am,
एकदम
like वो proper.
I'm not looking
हाँ.
at, yeah, very systematically I'm not looking at, but that solution has to be there, solved by you. So I should be able to see. I'll be checking that also whether you have solved or not. Okay, and time will be limited as I told you earlier, so don't waste your time in asking people.
And ma'am,
Questions will be different, values will be different. ऐसा नहीं है कि आप सब सेम वैल्यू आएगा, सबको अलग अलग रैंडम वैल्यू आएगा.
and ma'am, as you
क्वेश्चंस
said
भी
that
अलग हो सकते हैं.
we have to put the numbers in the input box. So there can be a slight fluctuation. So अगर वो Moodle automatically check करेगा तो समझो आपने आंसर में 2.7512 डाला है, but हमने सिर्फ 2.4.
वो टॉलरेंस है उसमें.
Okay, all right.
That tolerance will be added. अगर कोई discrepancies आते हैं, so I'll be showing you of course the marks at the end after everyone gives the exam. So कुछ ऐसे issues आते हैं तो we'll take it on a case by case basis. But that tolerance will be there, don't worry.
And also if the answer is wrong, so we'll
Write it up to 4
0.
decimal places. That is advised to you. Write it up to 4 decimal places. All answers, it will be written in the question only, up to 4 decimal places you have to write.
Ma'am, but if the answer is wrong, then we'll directly get a 0, or
Yes,
कुछ
yes,
working का marks होगा.
yes, directly you'll get a 0. I will see, first of all, Utkarsh, I will see actually क्या आपके results आ रहे हैं. If it is very poor, then I might consider the working. So that is why that working is very important, whatever you're uploading. Okay, so that you get some marks or something like that. Because क्या होगा वो 4 का सीधा 0 हो जाएगा, 4 marks का problem है. Okay, so I will see what is the performance. Based on that, I will change it. So don't worry about that. You focus on completing it properly and do it with honesty. Okay, that is what is important for you and for me also. Okay, तो इसका एक problem आपको चाहिए हर्ष, तो I will give you one other activation function, similar problem with the solution. Any other problem was remaining, that is MCPTA na. MCPTA, RDPTA if you do, that is enough. MCPTA I might not ask here because उसमें थोड़े calculations बढ़ जाएंगे. So RDPTA you be ready. MCPTA का भी फंडा वही है. You just instead of, see, in RDPTA we apply the perceptron learning rule. Okay, and in MCPTA we apply, it is continuous perceptron. You apply the delta learning rule. Both are for the output layers, because there is only a single layer of neurons that you're considering. It's not a multi-layered network at all. Both are for the output layers. What is the equation for that? You know what it is for perceptron. It is same. It is CD minus OX. What is for equation for delta?
CD minus O F dash of net X.
Exactly. बस यही फर्क है. तो नेटवर्क अभी अगर हमने बढ़ा लिया होगा ना ऐसे कुछ 5-6, तो I might give you 2 neurons only. छोटा नेटवर्क दे दिया.
मैम लेकिन वो टाइम कंस्ट्रेंट में डेल्टा का बहुत कॉम्प्लेक्स कैलकुलेशन होता है. मैं ओरली नहीं वो पूरा
वैसे ही सेट करूंगी कि टाइम should be appropriate. Don't worry about that.
मैम और वो RDPTA प्रॉब्लम्स में लाइक क्वेश्चंस में डायरेक्ट क्लास दिया होता है, आउटपुट वेक्टर जो डिजाइड होता है वो नहीं दिया होता है, तो वो खुद से लेंगे तो आंसर वेरी होने का चांसेस है ना.
हाँ, तो वो दिया रहेगा.
अच्छा, D-1 वैसा वाला वेक्टर दिया रहेगा.
हाँ, जो 1 है क्या है, वो -1 क्या है.
ओके.
See, if it is ESE problem ना, तो शायद वो नहीं दिया होगा, but in this case it will be given because I am looking at fixed answers, not MCQ. ठीक है?
Okay.
Any other doubts? EBPTA practice करना please. Maybe a simple network could be given.
Ma'am, total test time is 1 hour, right?
Total test time, yeah. So maybe 30 minutes for these problems. There'll be around four problems you'll have. Some might be small, some might be a bit long. You have to optimize your time accordingly. Okay, तो टाइम नहीं इधर उधर देखने को. You have to focus. जैसे आप क्वेश्चन लिखा, स्टार्ट किया क्विज, you have to start. That's it. Okay. So once you finish your lecture, जो भी है इसके previous, which lecture you have on Thursday before this?
DIP.
हाँ, so you make sure that you're coming on time. I will keep it a bit variable, but not much. Okay, 5 minutes का delay might be there. You have to
And
join.
it will be
You have to
one
join. You have to join on the link for the lecture. It will be what?
It will be one question per screen, like एक बारी में एक ही question आएगा, one question at a time.
Yes, yes, yes.
अच्छा, okay. And आगे पीछे नहीं होगा.
नहीं नहीं. One question at a time. Okay.
Ma'am, can you keep that like we can move so we can save time? Like if there is small question, we can attempt that
Okay,
first.
okay. I'll consider that. I'll check. Yes, I have whatever I'm doing. I'll let you know in the beginning. First 5 minutes, I'll give you instructions. Okay, and then we will start. So don't attempt the quiz directly. First, join the lecture. Okay, 5 minutes पहले join करोगे तो चलेगा. I will start, give you instructions, and then we will start with the test. Okay, all the best.